A rope is tied between an oak tree and a poplar tree. It is 40 meters in length. If it is pulled at its midpoint with a force of 360 Newton, what is the force exerted on the oak tree? Or in simpler terms, what is the tension on the rope? Now, to solve this question, first we would try to find the angle theta between the rope at its initial position and after it was pulled with a force of 360 Newton. The displacement caused on the rope after it was pulled sideways was 2 meters. Since we know the value of the base and the perpendicular of the right angle of the right triangle, we'd use the tangent theta equals to perpendicular over base, or theta equals to inverse of tangent of the perpendicular is 2 meters over base is 20 meters. Theta equals to 5.71 degree. Now we would use Newton's first law of motion, that is the sum of all forces equals to 0 at equilibrium. In this case, we would only use the forces in the y-axis, and since the forces on the x-axis, if we use for the base, it would be positive t cosine theta going towards the positive x-axis minus for this side negative t cosine theta. Which is 0. For the y-axis, we would use the force being pulled downwards, that is negative 360. When we add that to the force exerting upwards due to tension, and that's what equals to 0. For this case, we would try to find the force in the y-axis for both triangles. Since they are equal triangle, we can just double the force. And since we are using the one for perpendicular, it would be t sine theta, or 2t sine theta equals to 360, or t equals to 360 divided by 2 sine 5.71. It comes out to be 1809.16 Newton. So this is the force or tension exerted on the oak tree.